Assalamualaikum and hi to my panel. So today I will be presenting about my PSM1 project. So for my PSM1 project title is Fault Detection System and Smart Power Utilization using IoT monitoring for the PV system. So my name is MUHAMAD AFI bin Azim. My matrix number is CN180039 and my supervisor is Encik Omar bin Abu Hassan. So let me proceed to the introduction. So the introduction is about a solar PV system. A solar PV system is a photovoltaic system, also known as a PV system or solar power system. It's a power system that uses photovoltaic to generate usable solar power. So for the solar PV system have three types. For the first one is a on-grid system, that those systems which are connected to the utilization grid. So the second is off-grid system. Off-grid system is those systems which use photovoltaic technology only and are not connected to a utility grid. Usually require a battery storage to store the power energy. So the lastly is the hybrid system. Hybrid system is a system which use photovoltaic and more other form of energy, such as a diesel generator or hydro or wind. So this is a example picture of on-grid system, off-grid system, and hybrid system. Next is about the problem statement. There is have several problem statements in the PV system. A problem or condition to be improved in the PV system. In my project, I have three problem statements. The first one is the physical faults. Second is electrical and component faults. And lastly, third is environmental fault. So in the PV array system, there has a physical fault that contain internal and external fault. For the internal fault, have a damage to the PV module and damage to bypass diode on the solar panel. And for the external, crack in the PV module and degradation. So for the environmental fault, they have two types, that is permanent shading and temporary shading. So the lastly, electrical fault. They have several electrical faults in the PV system, such as open circuit, line-to-line fault, up fault, and ground fault. So for the objective in my project is, the first one is to investigate a fault detection system and power monitoring in the photovoltaic system. And secondly, to design and construct the monitoring of power photovoltaic system and fault detection using the Arduino Mega 2560 based on IoT application. So the lastly is to verify the photovoltaic monitoring, fault detection system and functionality, and to analyze the system efficiency and fault data. In this part, we will discussing about the project scope. My project scope is this smart monitoring which fault detection will apply to a standalone photovoltaic solar system that mean off-grid. Standalone system was typically use battery storage as a backup power source for utility or load. For the first one is I will use up to 10 watt 12 volt solar module, solar charge controller, battery storage with 12 volt 7Ah storage, power inverter, and connected to a load such as a lamp are used in the solar PV system as an electrical part. So secondly is in monitoring and control part, a voltage and current sensor are used to read the voltage and current that flow through the system. Temperature sensor are added to measure the temperature on the solar module. This sensor as an input data for a main controller in the circuit. Arduino Mega 2560 with Wi-Fi module are used to process the data received from the sensor to monitor and control the system. For the third, the system can measure voltage and current output as well as ambient temperature, compare the data to reference value, and send the information to the Blink IoT platform that has been chosen as an access from the anywhere on the internet. So for the last lead is a fault classification will be defined as a comparing real data voltage and current reading to the parameter value that has been configured. In the project flow, a method system used in a specific study or activity area. So this is my project flow that has been constructed. So the first is start selecting the title for the projects, data collecting and research, and finding information related to the title. That's mean doing some proposal for the title. And then listing a component and design a sketch of project of the system, selecting suitable component to the system that want to be used, and for the first draft, design and simulate using a Proteus software that has been chosen to design and simulate a result for the PV system. And then finalize a component and system specification, create a coding for a circuit using a Blink and Arduino software with Arduino Node or Arduino Mega. And then the software and hardware are set up and simulate and can be implemented in the system for the verification. So this is my second flowchart, that's for monitoring flowcharts and fault detection flowcharts. So for the monitoring flowcharts, the Arduino will be analyzed and Wi-Fi module will be analyzed, establish the connection to the internet, and then when the Wi-Fi module have connected, the Blink also will be connected synchronously with the Wi-Fi module. Input from the sensor will be read at the analog pin value on the microcontroller and sent to the Wi-Fi module via Blink serial and can be upload the data to the internet. For that, when the data have been collected, can be stored and displayed on the IoT platform, that's Blink. So for the right flowchart is about the fault detection flow. So this flowchart that show how the fault can be classified in the PV system. So this is a development phase for the PV system project. Block diagram for electrical part, solar panel, charge controller, and battery storage DC AC inverter are connected to a several sensors such as voltage sensor, current sensor, and temperature sensor. So this sensor will read the current and voltage that flow from the source of solar panel to the load. In this part is show about the block diagram for electronic parts. So can we see they have a temperature sensor, water sensor that have connected to the microcontroller Arduino Mega, and the output relay module to the water pump. So current sensor and voltage sensor are where the current and voltage are measured. Second is a microcontroller, which is a brain for the other component to work with each others. So the temperature sensor managed to control the output for the motor pump. That's DC motor pump to provide the water that will flow to the surface of the solar panel to prevent the overheating on the solar panel surface. Cloud where the data being storage. Finally, smartphone where the data present can be monitored in a real time. So using the Wi-Fi module as a IoT system, we can manage and monitor the data from the circuit directly using the monitoring system such as computers and smartphone. So for the flowchart, will show the solar parameter and temperature sensor that's collect data and be compared to the expected PV performance. With the expected PV performance, we compare with the actual PV performance to classify the comparison and fault detection. This is a simulation result that has been done in the Proteus. So can we see the current and voltage reading display with the power reading display. In this Proteus, I have construct two panels as the simulation part and connected to the voltage and current sensor. Voltage and current sensor will connected to the Arduino Atmega 2560 to collect the data and display to the LCD display. LCD display have shown the currents 2 amp voltage with 23 volts. That means the solar panel, each solar panel have 12 volt has been connected in series, and voltage will increase while the current will maintain. So for the right diagram show the power reading display 91 watt. This reading has been right in the source code using the Arduino IDE to calculate the current, voltage and power reading using the Ohm's law. In addition, I will show about the design has been constructed using the Proteus software. Can we see two solar panel has been used to supply the voltage and current through the current sensor to the Arduino Atmega 2560 and water sensor to the microcontroller, same as temperature sensor has been connected to the Arduino. This sensor will provide the data and send to the output LCD as the display. This simulation show the monitoring, not the fault detection. Yes, fault detection system will be conduct for the next projects. Can we see I use the potentiometer to control the voltage that has been that's flowed in the circuit. When the potential meter has dropped, the voltage and current will also drop. This potential meters works as a sun energy that solar panel will be absorbed flow. This is a Gantt chart for the PSM1 that have been done. They have several tasks that must be complete before the PSM1 end. So the first one is ideal communities and choose the title for PSM1. Second is topic selection and update at PSM that might be done every week. Third is determine and verify the objective, literature reviews, planning on the designing of a circuit, identify the material and component required for the system, doing the methodology to study the previous project that has been done, report and documentation, submit report to the supervisor to be checked before submitting to the panel, submitting report to the panel, presentation, and project completion. And finally, it's about my reference that has been used in my report. They have a total 23 reference that have been used to study about the project in my project report. That's for me. Thank you.